Now in this problem it is given calculate the stresses at critical regions, that is okay, using modified equations. Wheel load 6000 kg, capital E 3 into 10 to the power kg per centimeter square, slab thickness H equal to 20, modulus of subgrade reaction K 8, radius of contact area A is equal to 15. From that table you can easily understand SE. So use this formula, okay? Okay, it is given. How to get there? This formula, this. Okay, so I will not explain one again and again. You should remember this formula. These are given in that PDF file. It is there. Okay, formula sheet. So you get all those things, and similarly you are respecting there. So how to calculate L? You know that L formula AH cube 12K. What is this? 12K into 1 minus mu square to the power 1 by 4. Substitute all the values. See, very important. It should be in kg per centimeter square or centimeter. So kg and centimeter. Should remember to do that one. How to get this one? But L is equal to E value, H value, 12K 1 minus mu square. Okay, it is coming out to be 71.114 centimeter. Calculate B value. B value formula this 1.6 a square plus h square minus 0.675 h. 1.6 a square, a is 15. Again this is h square minus 0.675 h. You are getting B value 14.1 or 14.01. Edge stress formula. Okay, use this one. Put the values, you will get value of 30.5 kg centimeter square. For corner stress, what is this? SE 3ph square 1 minus a square a to the a square root of 2 divided by L to the power 1 by 2. How to get there? Yes, this is the formula. Okay. Okay. P value, H value, A, L substitution will get the answer 34.5 kg per centimeter square, corner and edge. Now in the next problem, what they have given, slab thickness 20 H they have given, constructed over a granular subbase having modulus of reaction K value, K is 15. The maximum temperature difference between top and bottom during summer day night is found to be 18. Directly temperature difference they have given T, small t. Spacing between transverse contraction joint is 4.5 and longitudinal joint is 3.5. The highest number 4.5 is capital LX, length of the panel. Smaller one 3.5, it is LY, width of the panel. Okay. Apart from that, they have given wheel load 5100, small a, E value, mu value, small e. Small e is what? Temperature, thermal expansion. And friction coefficient mu 1.5. Using edge and corner load stress chart, using the chart only, okay, calculate edge and corner due to wheel loads. Apart from that, they are asking to calculate warping stress. Warping stresses using the coefficient only, and critical combination they have asked. What is that? Edge region. Using the chart h equal to 20, k equal to 15, I am getting 24. How? Remember this value, h equal to 20, k equal to 15. Okay, we are all calculating at edge region. Well, how to get h 20, k 15? This one. Edge na h 20, k equal to this one. Okay, 15. So that is 24. That is 24. Like this. It's 24. Warping stress at edge. There is no calculation of Cx and Cy and EET by 2. First calculate small l, length of relative stiffness. EH cube 12k 1 minus mu square to the power 1 by 4. Substitute the values 3 10 to the power 5 E value, H value 20, 12 K value 15, 1 minus mu square, mu is 0.15 square. So you are getting 60.8. Now to get the graph you need Lx by L. This one no? You need Ly by L. How to get Lx? Lx is 4.5. It is clear. 450 centimeter. Ly 3.5 meter. 350 centimeter. So Lx by L 450 by 60.8. It is 7.4. Ly by L 350 by 60.8. 5.75. Using this and using this, you calculate Cx and Cy from the graph. How to see the graph? We'll go. Remember this value, Lx by L is 7.4. Cx is 1.02. I am getting 7.4 here, 7.4. So my value was 1.02. My value was 1.02. Here it is 1 and it is 1.02. Okay. Similarly, what was that? 6 point something was there, no? 5.75 was there. 5.75, it is 0.87. 5.75, 4, 5, 5.75. Okay, so I am getting 0.8 something, 0.85, 0.87, something like that. Okay, so 0.87. Now once you get Cx, Cy from the graph, substitute in this formula. Substitute in this formula. Okay, this is warping stress at edge. Warping stress at edge. STE formula value. Frictional stress formula value. WLF 2 into 10 to the power 4 only. Okay, not minus 4. WLXF, highest one we are taking. W, weight of the concrete, self-weight of the concrete 2400 kg per meter cube. L, length 4.5 and it is 1.5. Okay, kg per centimeter square. Okay, similarly, combined stress at edge region. Combined stress at edge region. How to get this one? Combined stress at edge region, critical combination, load plus warping plus minus frictional. Load plus warping plus minus frictional. Substitute the values 24, 75. This one you are going to get 50.74. You are getting what? 50.74. Okay. Here it is in meters only. You remember, it is in meters only, but answer you are getting it in kg per centimeter square. That the formula directly given like that. Kg per meter cube. Okay, meter. It is a F, frictional coefficient. Okay, this is the normal value. So you are getting it in kg per centimeter square. So it is like that only. So in corner region, load stress from chart, H20, K15, H20, K15, here it is. So I am getting more than 25, that is, I think it is 27, 28, something like that. 27, 28. Okay, like that. Now warping stress formula, STC, ET3 into 1 minus mu square root of A by L. Here it is for corner region. How to get that on corner region? Go to this table, corner region. This is the corner region. This formula I have used. Corner region. Okay, put the values, get the answer. So it is 10.51 I am getting. Frictional stress will be 0 at corner region. That is the standard. So critical combination, load plus warping. In corner no frictional stress will come. So load plus warping. 28 plus 10.51. This is a previous calculation, so I think some mistake I have done, so that is why I have made a strike mark. Okay, 28 plus 10.51 equal to 38.51. So critical combination of stresses at edge, which is more, that is 50 something is coming, no, 50, where it is 50.74 is more, is higher than the corner under identical conditions. Means same load, same temperature, also edge interior portion it is more, sorry, edge portion it is more compared with the corner one. Okay.